Hello and welcome to this Reigate Maths video on oblique impacts. This is a video for further mechanics. So we've dealt with particles hitting a wall in the first year work, and you should know that when a particle hits a wall with a velocity of u, it rebounds with a velocity of EU, where E is the coefficient of restitution between the particle and the wall. What we're going to look at in year 2 work is when the ball hits the wall at an oblique impact, so it doesn't hit it head on. So that's called oblique when this happens here. The angles of the path before and after, alpha and beta, they may not be the same. That they usually won't be the same. The velocity before and after will also not be the same, and so momentum changes. And what we need to consider is that the impulse acts at 90 degrees to the surface. That's the impact direction. So problems are solved by resolving parallel and perpendicular to the surface, and we look at the components of the velocities in both those directions. So if I look at the initial velocity of u, which is at an angle of alpha to the wall, then parallel to the wall, if we look parallel to the wall, we've got u cos alpha. If we look at the final velocity, we've got v cos beta. Those will be the same because parallel to the wall, there is no impulse. The impulse acts perpendicular to the wall. So parallel to the wall, the velocity is unchanged, but perpendicular to the wall, we will use the fact that the velocity afterwards, which is v sine beta here, is going to be e times the velocity before. You need to just watch directions with this because obviously it's coming in and then going back out again. So let's just have a look at one or two things that result from using this approach. So if we look at these two equations here, and we divide equation 1 by equation 2, let's see what we get. So I get u, I think we're dividing equation 2 first by equation 1. So I've got EU sine alpha divided by u cos alpha is equal to v sine beta over v cos beta. So cancelling the u's there, I get that E tan alpha is tan of beta. And that gives me that E is tan of beta over tan of alpha. Now we know that the coefficient of restitution is between 0 and 1. So we know that the coefficient of restitution is between 0 and 1. So that tells us that tan beta is greater than or equal to tan alpha. And because of the way the tan graph works, that tells us that beta, sorry, I've got these the wrong way around. So we should have here, so we've got tan of beta over tan of alpha. So we need, sorry, I've got my inequality sign the wrong way around there. Okay, so tan of beta has to be less than tan of alpha in order for this inequality to hold on this equation here. So that tells me that alpha has to be greater than or equal to beta. So that's saying that the angle it approaches at, it will leave at a smaller angle than the angle it approached at. So that's something that you should bear in mind when you're solving these questions. Right, let's look at some fairly typical problems here. So in this first one, we've got a ball moving on a horizontal plane when it strikes a vertical wall. So I'm going to draw what is a plan view here. So here is the wall. The ball strikes the wall at an angle of 60 degrees. And it is travelling with the speed of u, then it's going to come away at a speed of 30 degrees at a speed of v. So we've got all the information there on the diagram. And we are asked to find the coefficient of restitution between the wall and the ball. So in these problems, we're going to resolve parallel to the wall. So we resolve parallel to the wall. There's no change in the velocity. So that tells me that u cos 60 is equal to v cos 30. Perpendicular to the wall, we know that E times U sine 60 is equal to V sine 30, because we're using Newton's law of restitution now. So we'll call this equation 1 and call this equation 2. And I'm going to look at equation 2 divided by equation 1. The reason I'm doing equation 2 divided by equation 1 is that I want to get rid of the V's here and the U's, and that's just going to leave me with E and some tans or cots of different things. So equation 2 divided by equation 1 is going to give me tan of 30 equals equation 2 divided by equation 1 is going to give me E tan of 60 there. So we get that E is tan of 30 divided by tan of 60, which is equal to, when you work it out, 1/3. So the coefficient of restitution is 1/3. Notice that you cannot just write down this equation here. You have to show how you derive it, and it's important that you do that. Right, let's look at the next question. So again, we need to draw a plan view of this and see what's going on. So we've got a smooth horizontal plane, but we've got a vertical rule like that. And the ball collides with the wall and then comes away again. Although this angle here will be smaller than this, when I draw my diagrams, I don't always draw it like that because I'd like to leave myself enough room to fill in the values. So I've got U here and V there. We don't know the angle it comes away with. We know it approaches with the speed of U, and we know that that angle is 30, and we know that E is 1/3. So make sure that you've extracted all the correct information and put it on the diagram. So resolving parallel to the wall, you've got that U cos 30 is equal to V cos beta. So that's parallel to the wall. And then we're going to look perpendicular to the wall. Now, perpendicular to the wall, we've got E U sine 30 is equal to V sine of beta. So we've got that value there. We can put in 1/3 U sine 30 equals V sine beta. So again, I've got two equations, label them 1 and 2. I want to get rid of beta in this question because I'm trying to find the speed after collision. So I'm trying to find the V. So I'm going to use the fact that cos squared plus sine squared is equal to 1. So I'm going to combine equation 1 and 2 to do that. So I'm going to say that V squared sine squared beta plus V squared cos squared beta is equal to, so I'm going to have here, this is V sine beta, so I'm going to square all of that. So I've got 1/3 U sine of 30 is 1/2, all of that squared, plus V cos beta is U √3/2, and all of that squared. So that's my expression there. So I can say that V squared on sine squared plus cos squared, which is 1, is equal to U/6 all squared plus √3/2U all squared. And when we work this out, we get 7u squared over 9. So v is equal to root 7u over 3. And that is the speed of s immediately after the collision. If it asks for the velocity, then you might have to go back and find beta as well, but it doesn't do that, so we're not going to do that this one. Okay, the last question here. Again, we've got a wall, and we've got a particle hitting the wall and bouncing off, and it comes in with a speed of u, an angle of alpha. It comes away at a speed of v, and it's at an angle of beta. So it wants you to find, and we're going to have it in a algebraic form, it wants you to find the kinetic energy of S immediately after the collision. So if we look parallel to the wall, that my notation there is parallel to the wall, I've got that U cos alpha is equal to V cos beta. Perpendicular to the wall, I've got that E times U sine of beta is equal to V sine of beta. So those are my two equations. We want the kinetic energy. So we want a half mv squared. So what we're going to look at is working out a half m and then v squared from squaring these two terms here and writing it in terms of u and cos alpha. So the kinetic energy, well, let's just work out v squared first of all. So I've got that v squared on cos squared beta plus sine squared beta is equal to u squared cos squared alpha plus e squared u squared sine squared alpha. Just notice slight error there. That should be an alpha. So this is EU sine alpha is V sine beta. So apologies for that. So we've now got this equation here. So I can see that V squared is equal to all of this expression here. This section is equal to 1. So the kinetic energy is a half mv squared, which is going to be a half m. V squared is this expression here, so I can say that's u squared on cos squared alpha plus e squared sine squared alpha. And that would be my algebraic expression for the kinetic energy. So all of these kinds of questions are solved by resolving parallel to the wall and noticing that the velocity is unchanged, and resolving perpendicular to the wall because that's the direction the impact and the impulse happens, and using the fact that E times U is equal to V, which is the work you did in year 1. So if you go away now and solve some problems from exercise 5A, questions 1 to 4.